where we left off on Tuesday is we were going through the OWASP sort of top 10 list. And it is effectively a rank ordered list of what are the biggest sort of web vulnerability concerns. And it does change, over a period of every few years when they redo the surveys and reanalyze what is considered most sort of visible in the wild, or what security professionals are personally most worried about. And we went through the first couple, and we sort of left off here talking about injection, which I think if you were to look at either maybe other complementary resources or even looking at prior versions of this list itself, the top 10, historically this was one of the number one, the biggest web vulnerability concern. And the big picture is the idea that any web application that takes in user input, which is presumably all of them, right? They're not just sort of statically serving something. It's not a website, it is an application. So there's both user input and output. There's that client server relationship there. And it turns out that, at least historically in practice, it has been very difficult to guarantee that a malicious user could not input data that could then be interpreted as something completely different from what was originally intended. So we talk about injection. The idea is your application does require some input, and instead of just providing what is the expected range of input, you're providing something else. An attacker is providing something else that it could be interpreted in a more malicious way here. And there's a whole bunch of different versions of these injection vulnerabilities. We'll talk about sort of database injection. Another one that has been highlighted, at least historically in the past, is referred to as cross-site scripting. We did that in the lab, and I want to make sure we have an understanding of what is actually happening there. But the big picture is you have some user input, some user supplied data, and there is a requirement that there needs to be some sort of either validation of user input or filtering of user input, or another term is just sanitizing of user input to say, I'm expecting someone to enter in just some text information here, or uploading an image or something that's within a reasonable range of input values. I need to sanitize it to ensure that if in fact it appears to be something malicious that's getting inputted instead, I either just strip it, I just remove it, I just block it. I at least have awareness of that being the case here. One resource that OWASP offers for looking at their top 10 is referred to as WebGoat. Has anyone here played around with this software before? It wasn't that hard to install. It is in some sense an attempt to provide a bit of a virtual lab environment like we do in class, but it's really not meant to be at that extent to what we try to do in our labs for this class. It's a similar philosophy to other, hack the box, capture the flag type of environments, but specifically targeting the top 10 and what those attacks could look like in practice. We really can't go through all of these examples. They're first off, they're kind of subtle. It would take us a lot of time to go through and work our way through all these examples. We can look at a couple of them, but just for example, this is A3, this is injection, and there's a lesson on what cross-site scripting looks like in practice. Now, what will also have to be the case as you look at a lot of these web application vulnerabilities and exploits, many of them, including a lot of these injection attacks, assumes effectively some version of a man-in-the-middle type of attack in which I am providing via some input, some expected input to the web application, and someone along the way has the ability to intercept that request and modify that request, or intercept the response and potentially modify that response. So while ultimately the WebGoat is just a sort of locally running web application, you also need some sort of proxy service in between effectively yourself and yourself here to actually do those kind of experiments. Kind of a pain to set up the first time, but once you have it running, you can use it for all sorts of different things here. It arguably also leaves your machine somewhat in a vulnerable state while you have this up and running, because it's meant to show proof of concept that various vulnerabilities are possible, including ones that can impact your underlying system state. I think we're okay here for the most part, but if in the process of showing this off, one of you is able to break into my machine, then so be it. That should be worth some sort of extra credit, I would think. This is their page for cross-site scripting. It's meant to be kind of explanatory, also showing what can be done via just directly interfacing with the JavaScript console in this case, and ways in which you can then use user input to also provide sort of arbitrary programming functionality. So that's just showing opening up the JavaScript console. And this is in Google Chrome. I think it was Control Shift I. I don't know the actual keystroke. I just have muscle memory. You can provide any sort of arbitrary JavaScript input just to see what it would look like in practice, and that, if not protected against, can allow for all sorts of potential information leakage in your application. Again, this is myself as the user of the web application, also running the web service on the same machine. So you have to kind of squint your eyes and say that I'm intercepting traffic between my own machine and my own machine. It's just meant to be kind of a safe, standalone environment for exploring these kind of things. And then there's examples for all of these. So for this example, let's give it a try. Maybe I'll make it a little bit larger so you can actually read what's happening here. We'll have to go back and modify that projector again here. So it talks about the different variants of cross-site scripting, but this is very the textbook 101 version of it. So the idea is you have some sort of old school web application. Again, it's meant to be as kind of vanilla and explanatory, educational as possible. And the idea is, can we check if it's vulnerable to basically insertion of code here? So you have some sort of shopping cart where you're purchasing certain things and you're editing the quantity, and I don't believe that's a real credit card number. Certainly it's not mine. Don't go and try that. And then maybe some 3-digit access code here. And so this is asking, can we get this to do something that's unintended? And again, in this scenario, I am the user and I'm trying to kind of show the vulnerability in this application. You have other scenarios where there's a third party involved, right? There's someone potentially sitting between you as the user of the web application and the web service itself, who may be intercepting, modifying, or just reviewing the data that's getting passed back and forth. But then there's other scenarios in which you, just as the user, by having an insecure web application that allows you to potentially insert arbitrary source, one can do all sorts of quote unquote bad things in the system. Now, probably for our purposes, having it pop up an alert box in JavaScript is probably as far as one would want to go. And I think that's all it's really checking for here. What can we try? How can we get this to pop up an alert box? So the command is just called alert in JavaScript, or console.log is also fine, although to see that result, we'd actually have to have the console open, but that's fine. We can do either of those. How would we do it? Any thoughts? Sure. Yeah, and it looks like these boxes here are sort of numeric text boxes. So I can't really, it doesn't seem to let me type in stuff for those. But this looks to be, and as a design flaw, of course, sort of a unsanitized, arbitrary text field here. So presumably one can provide, or at least check to see if code is able to be run from it. Now, I think depending on how it gets interpreted. So actually, one thing you want to do is, okay, when I actually try the attempted purchase, what actually happens? Well, okay, it just prints out some message, thank you for shopping, and then it says we have charged credit card. So, and you can inspect that element if you want to see what that actually looks like in practice. And it looks like it's just HTML text, right? It's just, okay, took the values that were in that field and displayed them back to you. Again, simplified example just for sort of educational purposes here. So if instead we want it to do something a little bit more nefarious or unintended, it looks like it takes whatever's entered in here. It doesn't use this field at all, but this field, it takes whatever you've entered in, doesn't appear to do any sort of verification that it's sanitizing, that it's actually a credit card information. And we see that whatever we put in that field happens to get echoed back. That is still just kind of statically displaying HTML that we're interested in. There's lots of ways to insert things if something's not really checking for it, but we could just do sort of old school JavaScript brackets and we can have it call alerts. See, just have it say XSS. So we have arbitrary JavaScript code that's not intended. I don't know if this is going to work, but I think it should. And there we go. So just by hitting purchase, popped up an alert box, and presumably can hook into any other JavaScript that's eligibly run on that particular system here. That is just the WebGoat framework. It's kind of fun. Again, I think to get the most out of it, you want to have Burp Suite or something also installed on your system, because a lot of these exercises would involve intercepting and modifying these headers and calls and other things and seeing what havoc you can create in these examples. But in terms of this relatively dry topic of the OWASP top 10, it's kind of nice to have that side by side and say, okay, here is what the book says about number 3, number 4, number what have you. Here is just some sort of very basic simulator of what it could look like in practice. That is separate but maybe complementary to what we already do in the lab, which involves cross-site scripting, but not really all of these different scenarios. Because it does turn out that in practice that if you want to be able to show server-side request forgeries and things like that, you have to have several steps that have to be kind of manually taking place in order for the attack to be possible. This WebGoat does provide you that infrastructure. It has just the web application front end. It has like sort of separate user front end that they call WebWolf, and it's all just running in this nice, safe, self-contained place on your own machine here. Some of the examples they provide, a lot of them have to do with vulnerable sort of SQL calls in which we have some need to access something in our database as part of the interface for our web application. But perhaps if you have some sort of user input that is used directly without follow-up filtering or sanitation to construct those SQL calls, then really potentially at least anything may be possible. Those of you who've taken databases or are familiar at least have seen this kind of syntax before. So far, this looks reasonable. Select from account where the customer ID is equal to request.getParameter ID. So we had some ID field in our HTML, in our HTTP call here, and it constructs a SQL request from it. Well, depending on how that request is structured, depending on whether or not there's a framework or some other way of processing that input that's checking to see, was ID in fact just an ID? Or was it like our script call we had before, where you could then, even though it's supposed to just be an ID, and this is true for scenario 1, 2, or 3, on the next page here, it's supposed to be an ID if we're not checking for that, if in fact we're just allowing for arbitrary input to be provided, whether through a text field like in the example or via modifying the actual requests that are getting generated, then what could happen could be effectively a call to read from the entire database. And instead of just providing the exact information that's being requested, give me a union of all the tables in my database and return all the records from that particular table. And you can do all sorts of things. And once you have this ability to kind of arbitrary insert SQL calls into your database queries, then the game is kind of up, right? If you're protecting any sensitive information, it's very much at risk at that point. So when I mentioned kind of in the very beginning of this topic on Tuesday that I was referring to database security as sort of a separate aspect of web application security, this was effectively what I was referring to, this issue with SQL injection and just related database injection attacks. The issue in terms of covering it in much more depth in this class is that it's a whole separate topic, right? Understanding database systems. You do need to eventually get to sort of a bare minimum of understanding to kind of appreciate what's happening here. That, whether you wind up taking that course, which is a perfectly fine course or not, it depends on whether it fits into your degree program or not. You can get somewhat far by just playing around with the syntax. It's not entirely intuitive, I would say. You have to sort of get a feel for it over a period of time. But via, if nothing else, sort of trial and error, like this is a SQL try it out kind of website through W3 Schools, through effectively trial and error, you can get pretty far with understanding what is possible. You know, actual mastery would not also be obtained after the conclusion of one undergraduate course as well, right? This is a whole career field for people in terms of high performance database systems management. Um, but we can get pretty far by just, I think, as we've learned, just kind of playing around with syntax, seeing what works, what doesn't work. So this website just provides you just a very simple database, and you can then construct calls from that. From what you know of the records in that database. Let's do, that's not a lot of, let's do customers and not employee database. So here's 91 records of customers. And if I wanted to know of all these customers, how many of them are from the USA? Well, we don't know how to do that unless you've played around with database syntax before and have played with it. Well, there's a lot of 101 type of guides you could also follow. It turns out, and I'm probably going to get this wrong after saying how straightforward this can be, but select all records from the customer's database where um, country equals, I think it's single quotes, USA. If this doesn't work, I'm not going to fix it. Okay, and it did work, fortunately. So it's not obvious necessarily, and there's a lot of things you can do in terms of both the reading and writing and joining and merging of tables, and there's a lot to be learned. There's a reason it's at the very least one full undergraduate course on understanding this. But getting to that level of understanding is probably a reasonable goal for you, even this semester while taking this course. And it does turn out, that awareness and knowing that websites of most value are linked at some place to databases, and that those are a common target for attack via injection is probably sufficient as well. Which is to say, you're hosting a web server and you're looking at the various logs, and this wouldn't necessarily be the only way one would want to review the logs of what's happening with your web server. But you look at the Apache logs of all the requests that are coming in, and you do a grep for the keyword select, which again, that's the same SQL keyword we were playing with here. Literally checking to see if this is coming up anywhere in your logs. And when you start to see things like this, now, to be frank, I looked at this example, and I can't quite make heads or tails of exactly what it is doing. But for our purposes, that's probably still okay. Looking at that log, we can at least say it is trying to construct a very complicated, frankly weird looking database query. And unless you have good reason to believe that is something that's expected for your website, for your web application, that is a sign that there is some attempted, maybe automated intrusion in your system here. And you don't need to be a SQL expert or a database expert to look at this and say, well, something weird is happening, right? There's actually a couple things going on here. We have a GET request, right? We talked about on Tuesday for our WordPress, something with regards to a custom plugin that's checking a user. It's passing a user ID, and then we're also appending this really complicated looking database select statement on the end of it. Sounds like somebody is doing a test for potentially a vulnerable WordPress plugin there. And again, I think that's probably sufficient for now. Depending on what your particular role is in your organization, raising that red flag and saying, there's something going on here. Do we need to check that particular plugin and see if it's still considered reasonably up to date and secure, or do we have to disable it, or do we have to kind of take other remediary actions at that point? In terms of preventing injection attacks, I wouldn't say it is a solved problem today. That's not a fair thing to say. I will be curious when the next version of the OWASP comes out, the top 10, where it falls within that list of 10. It's a well understood problem, I think at this point would be a correct thing to say. That people recognize that whenever you have the potential for sort of user entered data in your system, you have to be careful to make sure it is not something that could be interpreted as code or as commands in your system. And most modern frameworks that people would be using today would have expected kind of programmer workflows for dealing with that. Things like, this is just an example, MySQL real escape string that takes anything that could be interpreted as a SQL command and kind of anodizes it and makes it relatively safe to kind of process otherwise. So ways of validating your input is usually not something that you would be expected to have to build and develop yourself, but that's what people have worked on in the ensuing years since this became a well-known published concern. And the state of the art is getting better with regards to standard frameworks and libraries that one almost has to create these kind of synthetic examples to get that kind of code to work in practice. That's not to say it's completely removed as an issue now, but it's a well understood problem at this point. This concept of assuming that all user input is evil or potentially malicious and needs to be sanitized is a very good way to think about programming in the first place. But specifically for web applications, once you're taking in user input, all sorts of bad things could potentially happen. We have that sort of defensive mindset as our starting point as a developer or as a system maintainer. This is one of the most famous, if not the most famous, XKCDs. And if you didn't understand it before, maybe now you get a sensible chuckle after having read it here, which is all I think you get out of these. So, call from the Sun School. We're having computer trouble. Did you really name your son Robert? And then database injection, drop table students. Oh yes, little Bobby tables. So they entered into the form. They didn't do server input validation, and in putting in his name, it deleted the whole student records. It's meant to be a joke, but that is an example of basically a SQL injection attack. And so if you see the term Bobby tables, that's what it's referring to. Probably not a real issue to that level. You don't have to look that far to see examples of what is effectively, whether it's injection attacks or whether it's just not proper sanitization of user input. I've seen this article publicized in a lot of places. I'm not actually convinced it's real or not, having tried to follow up. I try not to present, fake stories to you in class. I think we've done at least one this semester after having followed up on it further. They're still interesting whether they're real or not, right? So in this example, it's a little bit different, where someone in California got vanity license plate of null, and once he got a ticket, it was inserted into the database as null, not as the string null, but presumably as like a null byte representing his license plate. So can we guess what happened at that point? He got his first parking ticket, supposedly legitimately, actually earned that parking ticket. But then every other parking ticket in the system that didn't have a license plate associated with it, because people just didn't have valid plates or had no license plates or had them covered, got associated with the user with license plate null, and so they all were sent to him, and he received all those tickets for everybody who didn't have a license plate. Not quite the same as a SQL injection, but it's also not sanitizing user input. You only have so many bytes for your license plate, so there's only so many things you can do, but I guess that's one example that works. This one's a little bit more broad. This is category 4, or list on the number 4 on the list of just sort of insecure design. And that is meant to kind of separate the thought of something that is secure by design but flawed in implementation versus a web application that is just fundamentally flawed in its original design. One way of thinking about why this happens, and you may one day find yourself in a corporation where this is something you maybe have to fight for, is, at least historically, the security of application was always considered as sort of an afterthought, or sort of a cost, but not an actual benefit associated with building an application. And when that happens, what typically the issue is, it's not something that can just be kind of added after the fact, or at least not relatively easy. It is much less painful to start with a design that has security considerations in it, and then to continue to adapt and update and improve upon those, versus to start with something in which you didn't consider security at all, and then you have to try to sort of graft some security considerations on top of it. That was pretty standard for quite a long time. When we talk about some of these older CVEs, and how maybe with 2020 hindsight they seem so obvious. It was oftentimes kind of an artifact of the fact that we didn't think, or those who were developing those systems and applications weren't really thinking about security considerations at the time of development. Just some examples of insecure design. Um, you may have a credential recovery workflow that includes questions and answers. There are still all sorts of web applications that do this, even though it is now considered absolutely very bad practice. And by questions and answers, I mean if you've ever had to recover a password and it asks you, what was the name of your childhood friend or the name of your first pet? Has anyone ever encountered that even recently? It still in fact exists now. The fact that it goes against the OWASP top 10 is one thing, but it's also sort of prohibited by sort of government standards and expected, credential recovery workflows. Now, that is not a solved problem in and of itself as of today. People still struggle with the right way to provide beyond password account authentication and recovery, but it is pretty well understood at this point that a lot of people had a dog named Max growing up. And because of that, it's not a very good way to secure your account, because it's not something that's really limited to one person's knowledge here. These are a little, fluffy in terms of their description, because they're sort of results oriented. When you have a web application that's insecure, was it because of a flaw in the implementation? If not, if it was because of how it was designed to be implemented, this falls under this particular category. So you have a cinema chain that allows group booking discounts and has a maximum of 15 attendees before requiring a deposit. But if you had 14 attendees, it did not require a deposit, so attacker could just book the entire theater by doing it 14 or fewer seats at a time. Um, those kind of things are a little bit harder to nail down in terms of what the actual mistake was made. Really, it was about someone on the development team not game planning it through at the time of design and implementation. And for those of you who are in engineering or are certainly going to be working on, capstone style projects before you graduate, you're taking this class, you're presumably taking other cybersecurity classes as well. You may not be on a project that requires you to build a cryptographic engine or something like that. There's very few projects that fall into that. But most of these projects are building something, and quite a few of them, of course, are building web applications for these capstone style projects. It's really where your role is going to be and why you're a critical part of that team. Now, oftentimes for those projects, you are not developing an actual commercial website that's going to be expected to take real user information. But your role on the team is to consider the CIA triad, to consider what data is possibly being exposed via that application, and really consider security as a critical, equal part of the design process versus just functionality and features as part of the design process. And I mentioned this, but not to treat it as an add-on, but as part of the actual software development lifecycle. And that is kind of hard to do because it's seen and perceived by those who maybe don't have that experience or haven't failed in this regards in the past. It's seen as just as all downside. It's seen as extra cost, extra time, extra slowness of getting to market. But it's very hard to fix after the fact versus working on it as you are designing your application. I like this book, which is actually about business. It's not about cybersecurity. Only the paranoid survive. That's a nice way to think about web applications as well. You need to have at least one person on your team, and we're talking even a team of 4 or a team of 5, who is contributing in other ways, of course, to the project, but is the paranoid person on the team. And at least is raising the issues of where things can go wrong based on considering things like top 10 related issues here. Whether they all get addressed is a factor of budget and time and things like that. But having that paranoid person who is modeling what can go wrong as part of the design will lead to a better outcome. I guess the irony of this book is Andy Grove was the chair of Intel, and Intel did do a very good job with cybersecurity modeling, both in software and certainly in microarchitecture as well. But as a philosophy, I kind of like it. It was a business philosophy. It's a pretty good book. As a cybersecurity philosophy, I think it's a very good way to think about it. So this is related, but not exactly the same thing. The previous one is where the design was built without thinking about security or not considering it a priority in your system. This is more so where you are presumably using various frameworks, other libraries, applications, and you happen to have insecure choices for what would otherwise be sort of a legitimate configuration of that system. You can also think of that as just kind of bad defaults, which is not necessarily your fault. You didn't necessarily build the framework or the library or the third-party application that's part of your system, but you have to have a sufficient knowledge to know that perhaps by default it leaves open an administrative page that has well-known published default credentials. So as part of that, one has to consider really the entire software stack and have sufficient knowledge, as we've been trying to gain this semester, but as you'll continue to gain over time, of what are the security implications at all those layers of your software stack. This is again a little bit fuzzy as well, but just consider that what are the defaults of this various part of my application, the various parts of the stack that I'm using, which ones would then also have that security consideration that maybe weren't taken into account, or you're using something not for its originally intended purpose, and so there's security implications of that merger of goals and needs there. So scenario one still happens all the time and happens in multi-billion-dollar companies as well, that they use a particular piece of software that comes with either default users or sample applications, and it's always someone else's problem on the team or in the organization to make sure that those get removed. And oftentimes, those sample applications are just meant to be examples. They're not meant to be kind of moved directly into production, but depending on time, budget, expertise, that does wind up happening. And we'll look later this semester at all sorts of scenarios that were effectively that. Otherwise, when you're using some software that's certainly not your own, and we're all going to be doing that as we build web applications, think about what the defaults are. Try to understand what the defaults are. Some of this gets exposed via using some of these third-party audit tools of the types we've been looking at already, but at the time of design, can we consider that as well? Okay, we're using this framework, we're using this web server even. What does it provide for us by default? What things do we instantly kind of have to lock down once we have this particular piece of software installed? Using software as a mitigation with well-documented hardening procedures. Surprisingly large number of web application security issues have to do with WordPress, just a content management system. A good WordPress installation isn't obvious that it's WordPress, but then there's lots of sites that use WordPress and it's very obvious that they are using it. I have the WordPress hardening guidelines open here. Some of that's very specific to WordPress and to using various web servers like Apache to host a WordPress site. What was interesting to me, and that link's available in the slide that you can take a look at. Again, first off, if you look at CVEs related to web application, WordPress continues to come up over and over and over and over again. It's got a nice open source, extensible software ecosystem. And to be frank, it is people who aren't software or security experts writing plugins and things like that because they needed a piece of functionality and they built it themselves. And so there's a lot of that. You look at this hardening guide, and some of these things are very not straightforward to me. So our department, our university, has all sorts of WordPress sites that it is running off of, as we looked at earlier in the semester. And exactly making sure you have the exact right default permissions on everything within your WordPress install, as well as having various, and this is a HT access for Apache, various rewriting of what the links need to be, so you're kind of not providing sort of the default where all the administrative interfaces are for these things. That's there's actually a lot here, and it'd be a fun project to look at Iowa State's WordPress, or maybe look at our departments. Don't look at Iowa State as a whole, so you'll get in less trouble that way, and see which of those best practices are actually being followed. And I don't believe a lot of them are. This is related to another one that comes up, which is understanding updates as well. To require is to retire is the kind of hackneyed phrase that people like to use. The idea is that if you have a WordPress install and you have 37 packages that you need for your website to look exactly the way you want, you're not responsible in some sense for those 37 packages. And what will happen is, again, that's really, in a sense, 37 different software vendors that you're now responsible for following up on and understanding where they're at from a security posture perspective. And you have to sometimes make difficult decisions with regards to that. You have this plugin, it does exactly what you need for your website, and you realize the person who maintained it gave up on it 2 years ago. They moved on to other things in life. They found something else they wanted to work on. And now something has been discovered in it. You have to make that decision now. I really like this feature. Am I going to keep this feature? Am I going to retire this feature? Am I going to try to fix the feature myself to get what I need in terms of hardening of that particular plugin? One of those things I think that sounds straightforward is, well, I just won't have any insecure plugins on my website. Couple things, right? You may not be in charge of that decision, right? You may be on the audit compliance team is part of your organization, which may or may not be a software organization, right? It may be an organization that makes widgets and just needs a website, needs a web application to support their widgets. And so it's not always as straightforward as to say we're going to design everything secure by default. We won't use any potentially suspect third-party plugins. We won't have issues with security misconfigurations. Um, there's no guarantee that you would have that authority to make that decision in the first place. You have to be the one who can raise awareness when these issues are discovered. This is directly related to what I just mentioned about the plugins. This is number 6, which is vulnerable and outdated components, where the application itself is fine, but the libraries or components it relies on or are not. It's directly related to the prior one. You think you're installing one application, you're using one framework, but for that framework to work properly, it's actually pulling in so many other people's code, so many other kind of sub-frameworks, sub-libraries, whatever you want to call them, just components that may or may not be secure. Couple places, we looked at the Apache struts example before, in which it was a very common plugin that people were using for Apache. It turned out to, with very simple modification of headers, allowed for the execution of arbitrary code here. And the issue is that when you have all these plugins, they're running effectively with the same privileges as the application itself. So your application may be regularly updated, your web server may get regular updates, and you're constantly checking and monitoring that. So your WordPress install may in fact be fine, but what about the 36 or 37 or however many plugins that you are using here? This is pretty difficult when we move beyond web application as we talk about IoT and related security considerations. Again, Internet of Things, there's different focus areas that are important for us. It's still a software application at the end of the day. Just like a web application is still a software application at the end of the day. That's a different software ecosystem it's pulling from, but the difference there is presumably with a web application, there is some mechanism by which we can do those kind of updates. With IoT, that's not always necessarily the case that we can update vulnerable or outdated components in our system. What you require, you must also retire. So that is easier said than done until you find yourself in a situation in which you have a feature that you need, but your audit, your Nessus report, your scanner report tells you that this feature that you in fact believe you need is a point of pain, is a security consideration for your application. It's very easy for us, in the classroom to say, well, just don't use it, or just fix it ourselves, or just build our own version of it. Raising awareness of those issues, kind of considering the trade-off space involved in that is something that makes this kind of line of work not that easy. Let's leave it here. We got through 6. We'll get through the last few on Tuesday, and then we'll get to move on to a topic beyond this as well. Otherwise, I'll see a couple of you this evening, and enjoy your weekend.